Hi everyone. We covered time value of money last time, and there's a couple additional aspects to this which I hadn't covered last time, and that's what we're going to be going over in this video. So if you remember from last time, these are the two equations that we had essentially arrived at. One of them, the one on the top over here, shows you how you can calculate the present value given that you have the future value, the opportunity or the rate of return, as well as the number of years. And this one is the exact opposite. It tells you how to calculate the future value given that you have all of these as inputs. Okay. And just by way of an example, just to refresh your memory as well, let's say your present value or the value that you have right now is £100, and that is at time zero. Your opportunity is to invest this at a 10% rate of return. And you want to know what the future value of this will be. So the value after 1 year. And we calculated this last time just using the future value formula that I showed in the previous slide. And that is 100, that's your present value, multiplied by 1 plus r to the power of 1, because it's 1 year into the future that we want to find this value of. And that gives us 110. But n over here is 1, and that refers to 1 year into the future. But previously, we looked at n being 5 for 5 years into the future, or 10 for 10 years into the future. But there's no compulsion that n has to be a whole number. It doesn't have to be 1, 2, 3, 5, 10, whatever it is, right? So say you have £100 now and you wanted to find out, well, how much is this going to be worth in 6 months' time? Right? So 6 months is 0.5 years, it's half a year, right? And you can use the exact same formula that we used all of this time to calculate what it will be worth after 6 months as well, right? So that is 100 multiplied by 1 plus r, your opportunity or your rate of return, to the power of 0.5. And that 0.5 is to represent half a year or 6 months, right? And in this case, that happens to be 104.88. Okay. And you can also find out, well, how much is it going to be worth after 0.75 years? So that's 3/4 of a year or 9 months, right? So you're trying to say, if I have £100 now, how much is that going to be worth in 9 months' time? And again, the exact same formula, 100 multiplied by 1 plus your rate of return or your opportunity over here, which is to invest it at 10%, to the power of 0.75. And that gives me 107.41. Right? So even though in previous examples and likely in examples going forward, n is most likely going to be a whole number, a 1, a 2, a 5, or a 10, you can just as easily apply it to fractions as well, right? So it's 0.5, 0.75, or even 1.5 or 2.5 to represent 1.5 years, or 2.5 years, or 2.75 to represent 2 3/4 of a year. And it can also be 0, right? N can also be 0. And again, if you put that into the formula, this is what you get. You get 100, right? And the reason for that is because 1 plus 0.10 to the power of 0 is equal to 1, right? And I've put that over here on the top right. Anything to the power of 0 is just 1. So you're saying 100 multiplied by 1 is equal to 100, right? So what is this trying to answer? Well, it's essentially trying to say, if you have £100 now, how much is that going to be worth in 0 years' time? Well, 0 years' time is now, right? So another way to phrase that exact same question or statement is, if you have £100 now, how much is that going to be worth now? Well, you know what it's going to be worth now. It's going to be worth 100. Okay. So we've looked at whole numbers, so n can be 1, 2, 3. We've looked at fractions, n can be 0.5, 0.75, 0.25, 1.5, anything like that. It can also be 0, right? That's to represent the value of something right now, right? But it can also be negative as well, right? So here we have £100 at time 0, and we want to know what it will be worth in -1 years. So another way of saying this is, if I have £100 now, how much would it have been worth 1 year back? And again, exact same formula, you can just use it and you can find out that it's going to be worth 90.90. But what exactly is this trying to tell us? I mean, one way of thinking about it is, just as I mentioned before, if you have £100 now, how much is it going to be worth 1 year back? Or how much would it have been worth 1 year back? But this is interesting because there's another way of rephrasing this exact same question, right? So if you remember, this is exactly the same calculation that we did in the previous slide. And if you also remember, anything to the power of -1 is just 1 divided by that thing, right? So another way of writing up this exact same equation is this. All we've done is we've taken this figure 1 plus 0.10 to the power of -1, and we've changed that into this. And that's because anything to the power of -1 is 1 divided by that thing, right? And now all I'm going to do is I'm going to multiply the 100 into the brackets, and we're left with this. Now this looks very familiar, and I've put this equation, the present value equation, on the top right, and this looks very much identical to that, right? 90.90 is the present value, or the value at time 0. 100 is the future value, in this case at time 1, because we're looking 1 year ahead. 1 plus r, that's what you have in the denominator, and it's all raised to the power of n, but in this case, n just happens to be 1. It's 1 year into the future, and that's why we've chosen to exclude it. Right, so I've put the question that we're trying to answer over here on the top right, which is, if we had £100 now, how much would that have been worth 1 year before? But another way of rephrasing that exact same question is to say, well, if I am to receive £100 1 year from now, how much would that be worth now? Right, so this is coming back to the previous slide where we said that this was the present value, this was the future value, and the time period was 1, and the rate of return was 10, right? And this one we're familiar with because we've seen this before, right? This is now, this is the future. We can just discount this by doing 100 divided by 1 plus 0.10, and we can calculate the present value. And both of these are identical, right? And that also covers something quite important, which is we don't actually care the absolute value of the years. We just care about the gap between them, right? And that's why in all of the examples that we've gone over so far, I haven't specified that this year is 2023 and 1 year ahead is 2024, or this year is 2030 and 1 year after that is 2031. And that's because it doesn't matter. All that matters is there's a 1 year gap between them, right? So we don't really care about the absolute time period that we're in. We just care about the distances between them, the gaps between them. Okay. Now we've looked at the present value and calculating the present value given the future value, and we've done it the other way around as well. So if you have the present value, how you can calculate the future value from it. But now, given this equation, if I give you the present value and the future value and the number of years as well, then you can just as easily calculate what the rate of return R, or the opportunity, should be. Right, and that's what we have in this example here. We have £100 being the present value, we have 110 being the future value, and that future value is after 2 years. So what is the rate of return that will allow me to get 110 in 2 years' time if I am starting off with 100? Right, so the present value in this case is the 100, that's what we have over here. The future value in this case is the 110, and that's what we have over here. And 1 plus r to the power of n now becomes 1 plus r to the power of 2, because it's 2 years into the future that we're looking at. And now you have an equation where r is the only thing that's unknown, so you can just rearrange this equation, make r the subject of it, and you can quite easily calculate r to be 4.88%. right? So 4.88% is the rate of return which will allow you to get 110 in 2 years' time, given that you're starting off with 100, and the rate of return is 4.88% for that, right? Now, there's a way of checking what you have done is correct, right? We've just said, well, if my present value is 100 and I want to get 110 in 2 years' time, then I need a rate of return of 4.88%. Another way of asking that same question is, if I have £100 now and my rate of return is 4.88%, how much will I end up with after 2 years? And hopefully, if we've done everything correctly, it should give us 110, because we'd used both of these inputs as well as the number of years to calculate this. So now if I use this as an input, this as an input, and this as an input, then I should be able to calculate that 110. Well, let's see if that is what we get. This is our present value, it's 100. Our rate of return is 4.88%, and we're looking at the value after 2 years, and that's why we're raising it to the power of 2. And that equation gives us 109.998, which is basically 110, the figure, the future value over here, right? The reason for the very slight difference is because this isn't exactly 4.88%. I've missed out a couple of other decimal places. It's actually 4.88 something something percent. Had I put in the exact value, it would have given me 110. But in this case, you get to see that it's very close to 110. So we've just confirmed that our rate of return that we calculated is correct, right? So if you do calculate anything, it doesn't just have to be your rate of return. If you calculate your present value or your future value, you can input it back into the equation and see whether you get the same outputs that you started off with, right? If you do, then that means that you've done your calculations correctly. Otherwise, there's something that's gone wrong somewhere, okay? And that brings us to the end of what we wanted to cover, or what I wanted to cover today, the couple of additional aspects of time value of money. Thanks everyone for listening.